Our next talk is by Nick Silver, a PhD student at the Department of Biochemistry, whose talk is titled Why Protein Shape Matters.
In 2017, my grandfather was diagnosed with Parkinson's disease. When you hear the words Parkinson's disease, you likely envision someone with a tremor or perhaps difficulties walking. But if you were to meet my grandfather, the first thing you would notice about him is that he is completely delusional. My grandfather is part of over half of all Parkinson's disease patients that go on to develop Parkinson's disease dementia. My research tries to understand why only some patients develop Parkinson's disease dementia. The underlying cause of Parkinson's disease is thought to be the abnormal accumulation of a protein in your brain called alpha-synuclein. In Parkinson's disease dementia, the majority of patients also accumulate a second protein in their brain called amyloid beta. Amyloid beta could be key in the development of Parkinson's disease dementia, so why does it only accumulate in some patient brains? Think of proteins as tiny machines with specific shapes and functions. Imagine alpha-synuclein is like a wheel. It has to be round to be functional. In Parkinson's disease, our normal round wheel-like protein will take an abnormal shape, like a triangle or a square, loosen its normal function, and accumulate it in your brain. I believe specific abnormal shapes of alpha-synuclein will allow the secondary accumulation of amyloid beta where others would not. To test this, I took mice that had both proteins in their brains and got them sick with different abnormal shapes of alpha-synuclein. When I looked at their brains, just as I predicted, only certain abnormal shapes of alpha-synuclein enhanced the secondary accumulation of amyloid beta, where other abnormal shapes inhibited it. However, what was more exciting is the male mice got sick before the female mice and had more amyloid beta in their brains. This is exciting because males are 2 times as likely as females to develop Parkinson's disease dementia, and this data indicates there may be underlying molecular mechanisms making males inherently more likely to develop the disease. My research really highlights the importance of different abnormal shapes of alpha-synuclein in disease and underscores sex is a biological variable. In the future, by identifying the abnormal shape of alpha-synuclein in a patient, we will be able to predict if they will develop Parkinson's disease dementia and create targeted therapies for this disease. While my research is about proteins and shapes, its essence is really about families, like my own, and giving them a clearer understanding of this disease and hopes in the future no one will face the same challenges as my grandfather. Thank you.